Welcome to Light Academy. From today, we're going to be answering past questions on IJMB mathematics, and we're starting from 2003, paper 1. And the first question goes thus: differentiate tan 1 minus x squared cos 3x. Looking at this equation, you notice that we are to use product rule, because tan 1 minus x squared is one part and cos 3x is another part, so we're going to use product rule in solving it at the end. But before then, we have to differentiate each of the terms one after the other. And the first one we're going to start with, we're going to differentiate cos 3x using chain rule. Cos 3x, cos 3x. We want to first differentiate cos 3x. Say let y be equal to cos 3x. Please don't mind the background noise. And let y be equals to cos 3x. And since we are looking for cos 3x, now I want to differentiate cos 3x. Okay, and we have to differentiate them one after the other using chain rule. And for us to get chain rule, we have to split them and differentiate them. First of all, let's say let u be equals to 3x. Therefore, y will be equal to cos u. This y will be equal to cos u, since u is now 3x. So now differentiating differentiating 3x du dx is going to be 3. Now let's differentiate this other one, cos u dy du is equal to minus sine u. And for chain rule, we are going to multiply this by this to get dy dx of y is equal to cos 3x. Dy dx is equal to du all over dx times dy all over du. So therefore, finding the differentiation of cos 3x, d cos 3x all over dx with respect to x is equal to, our du dx here is 3 times, and now the y du is minus sine u, which is equal to minus 3 sine u. We're not going to stop there. Remember that we said that our u was 3x. Then we are going to repeat into the answer, getting minus 3. Differentiate tan 1 minus x squared. arctan 1 minus x squared. We have differentiated this one. Now let's differentiate this one. Go with me. Y is equal to arctan 1 minus x squared. We are still going to use chain rule as usual. We are still going to use chain rule as we did with the first one. So we say let u be equal to 1 minus x squared and y equal to arctan u. I don't know if you are getting it. Arctan u. Du dx. Differentiating 1 is 0. We bring in the minus down. Then differentiating x squared is 2x. Let's get to this one. dy du is equal to 1 all over 1 plus 2 squared. When I get to the end of this explanation, I'm going to explain how I got 1 all over 1 plus u squared. But this is something that as students we have to have it at the back of our mind. But if you don't know it, I will show you how to derive it. 1 all over 1 plus u squared. Multiplying this and this, dy dx is equal to du dx times dy du. And we are looking for we have to differentiate down arctan 1 minus x squared dx is equal to our du dx is minus 2x times, this dot signifies times, dy du is 1 all over 1 plus u squared. I hope you are getting it. Let's change this paper. So now we're going to multiply the equation we got. Let me write it out here for clearer understanding. I'm sorry for the background noise. D arctan 1 minus x squared dx is equal to minus 2 times 1 all over 1 plus u squared. Minus 2 times 1 is minus 2, going to be minus 2 all over 1 plus u squared. And remember, our u was 1 minus x squared. I'm sorry, I can't get the paper off. I can still bring it back. Sorry. Our u here was 1 minus x squared. So we're going to substitute this 1 minus x squared into u. So we're going to have minus 2 all over 1 plus brackets, showing that there are two brackets of its kind. So it's going to be minus 2x. Sorry, I threw away my x. I'm bringing it back. I threw away my x and I'm bringing it back. Minus 2x minus 2x. I brought it back. Please, in the exam hall, don't throw away your x. Just note what I'm carrying along. All over 1 plus, I'm expanding the bracket, 1 minus x squared. 1 minus x squared. Minus 2x all over 1 plus, I'm going to open this bracket, 1 times 1, give me 1, 1 times minus 2, 1 times minus 2, I'm putting this bracket because of this plus here, 1 times minus x squared is minus x squared. Minus x squared times 1 is minus x squared. Minus x squared times minus x squared is going to give me plus x raised to the power 4. Minus times minus is plus. And x squared times x squared. Remember our rule, you sum up the powers. Index rule, you sum up the powers. So I'm going to have minus 2x all over 1 plus, I'll open the bracket finally, 1 minus x squared minus x squared plus x raised to the power 4. This is going to give me minus 2x all over 1 plus 1 is 2 minus x squared minus x squared will be minus 2x squared plus x raised to the power 4. This is how to differentiate arctan 1 minus x squared. I've gotten an answer for this. Now let's go back to the main question. Remember, I told you that the main question was to use product rule. So the main question is going to be y is equal to arctan 1 minus x squared cos 3x. And what's our product rule? Our product rule, dy dx, sorry about the background noise, is equal to v du dx plus u dv dx. This is the product rule. Call it product rule. Sorry about the background noise, I'll still say it again. Okay, from this question we have been given, we will say let our u be this. We are doing we are going to multiply them. So in multiplication, in this place we are going to have multiplication will be like u times v. So we say let this one be our u and cos 3x will be our y. So we're going to say let u be equal to tan arctan 1 minus x squared and v is equal to cos 3x. As usual, we have to differentiate u with respect to x. So du 3x is to differentiate arctan 1 minus x squared. Remember, we have already differentiated it, so we're going to lift this our answer into this place, giving us minus 2x all over 2 minus 2x squared plus x raised to the power 4. And dv dx, we already differentiated cos 3x, and our answer was minus 3 sine 3x. I just hope it's understandable. So we're going to put in this terms. We're going to substitute this what we have gotten here into the product rule. That will be on the next sheet. Therefore dy dx was equal to, here our product rule was v du dx. That was our product rule, plus u dv dx. Okay, let me write it here for clarity's sake. Okay, no. Yes, let me write it for clarity's sake. V du dx plus u dv dx. And remember, our v here was cos 3x. So we're going to substitute it into the equation. Everything here that I've got, I'm going to substitute into the equation for you to get it. And I know you have been following me step by step. So for you to get it, you can go backward the video so that you can get what I was saying if you don't understand it. So our v was cos 3x, and our du dx was minus 2x all over 2 minus 2x squared plus x raised to the power 4. Bring this plus sign down here. Our u was arctan 1 minus x squared, and dv dx was minus 3 sine 3x. Don't mind if I have my companion. They're helping me to teach. Okay, we're going to simplify this answer. So simplifying the answer, cos 3x multiplied by 2x minus 2x is going to give me minus 2x cos 3x all over 2 minus 2x squared plus x raised to the power 4. Now to simplify this, there's a plus sign here and there's a minus sign here. Plus times minus will give me minus. I'm going to bring this 3 in front. 3 arctan 1 minus x squared sine 3x. So this to differentiate arctan 1 minus x squared cos 3x. I hope it's understandable. Then I remember saying I was going to show you how to differentiate arc tan x. Differentiate arc tan x. You are supposed to know it at the tip of your fingers. Okay, let's say y is equal to arc tan x. You take the tangent of both sides, giving you tan y is equal to tan into arc tan x. This one will cancel this one, so it's going to be left with tan y is equal to x. Have this at the back of your mind. Call it equation 1. The next step is to differentiate both sides of the equation. Differentiate both sides of the equation implicitly. I want you to take note of this word, implicitly. If you are differentiating implicit, we are going to give reference to y. So differentiating both sides of the equation, that's having d dx of tan y and d dx of x. D dx of tan y is sec square y. This one I know they must have taught you derivatives of tan, cos, sec, of tangent, cosine, secant, and all the rest. Sine and all the rest must have taught you. So differentiating tan y is sec square y. Since I'm differentiating it implicitly, I'm going to give respect to the y. Anytime I differentiate the y part of the equation, I'm going to attach dy dx to it. That's when they say implicitly. Anytime you differentiate the y part, you must attach dy dx to it. So differentiating x, it's going to be 1. The next step is to make dy dx the subject formula. That's to divide both sides by sec square y. Sec square y divided by sec square y. This one comes with this one. Dy dx is going to be 1 all over sec square y. Remember one of our derivatives that we got. Remember cos square y plus sine square y is equal to 1. And I hope you remember this. You must have been taught. We're going to divide through by cos square y. Cos square y. Cos square y. Cos square y. This cos square y divided by cos square y is 1. Sin square y divided by cos square y is tan square y. And 1 all over cos square y is sec square y. Remember, dy dx is equal to 1 all over sec square y. And what's our sec square y here? Sec square y is equal to 1 plus tan square y. And remember that we said from equation 1, x is equal to tan y. Therefore, x squared will be equal to tan square y. Therefore, dy dx is equal to 1 all over 1 plus tan square y is x squared. You can use any letter x, u, v, and all the rest. So that's how to differentiate tan arctan x. I hope it's understandable. Have a nice day.